this is David Burget back with the AI Impact Series Episode 3. This time we are here focused on how AI works and how you as a business leader can harness AI's extraordinary potential while managing the risks. We all experience AI every day, but you may not notice it. That's because AI is deeply embedded in most top-selling devices and web applications today, enhancing and personalizing our digital experiences. It has 4 primary capabilities or superpowers: prediction, anomaly detection, communication, and vision. First, AI is incredible at spotting patterns in data to predict future events. Think of stock price forecasting, predicting weather patterns, or even understanding customer buying behavior. If you've watched a new Netflix show, purchased a product on Amazon, or found a new artist on Spotify, you can thank machine learning algorithms for the suggestions. Second, AI is great at anomaly detection. It can identify unusual occurrences in massive datasets, alerting you when something is off, say in your network security or spotting fraudulent credit card transactions. Third, AI is a great communicator. It has the ability to understand and generate human language. That includes the broad field of natural language processing, which makes voice-to-text, language translation, and classification possible. It's also the field powering human-computer interaction in platforms like ChatGPT and Google that can magically respond to your prompt with unlimited creativity. And lastly, AI can see, recognizing text in documents and objects in images and videos, often in systems like autonomous vehicles or facial recognition. And with generative AI, you can now turn your text prompt into a work of art, product design, or fictional reality. When most people talk about AI and its superpowered capabilities, they're referring to machine learning. There are 3 main strategies for teaching machines to learn, recognizing patterns and making decisions: supervised, unsupervised, and reinforcement learning. Supervised machine learning is far and away the most common type of machine learning in use today. In it, models learn from labeled data, like a teacher guiding a student based on information from the past. The teacher provides the algorithm with input-output pairs. The goal for our model student is to learn the mapping function or algorithm that best connects the input features to the output target. Let's consider a real-world example. Zillow, the popular online real estate marketplace, uses supervised machine learning for its Zestimate, the predicted market value for homes. Zillow has access to a massive amount of historical home sales data, with details like size, age, and the actual price at which homes were sold. They train their Zestimate model on this data, and it learns to link features of a house, such as its location, size, and age, with price. With each new sale, its model gets a little better. But keep in mind, supervised learning models are heavily dependent on the quality and quantity of the historic data. If the training data is biased or not representative, the model's predictions will reflect that. Moving on to unsupervised machine learning. It allows you to see hidden patterns in datasets when you don't have labeled data. These models work by identifying complex patterns, correlations, and structures within the data. There are 2 common techniques used in unsupervised machine learning: clustering and dimensionality reduction. An example of clustering is organizing customers into groups. For example, an algorithm might look at a customer dataset and naturally split them into clusters based on characteristics it identifies, like shopping behavior, demographic information, and purchase history. It might determine there are groups like young gadget enthusiasts and senior home goods shoppers. It doesn't know what a gadget enthusiast or home goods shopper is, but it sees patterns in the data and creates groups accordingly. This automated grouping can help marketers tailor their strategies to each customer group. While clustering helps group similar instances together, dimensionality reduction simplifies a dataset by reducing the number of features while retaining as much of the important information as possible. For example, taking a dataset with 100 columns or features down to the most important 20. That saves storage and compute costs when modeling. One limitation of unsupervised learning is there's no ground truth, and without an explicit reference for an answer, it's difficult to measure the accuracy of the model or to know when it's making a mistake. Reinforcement learning is a more recent approach to machine learning, where an AI agent learns through trial and error in an interactive digital environment. A simple way to explain it is in the world of video games. Here is an example of teaching a reinforcement learning agent how to play the game Snake. First, you teach it the rules. It can move in various directions, and that its goal is to eat as much food or little dots as it can, while avoiding walls or its own tail. Knowing this, the AI will play the game millions of times and continually learn and optimize how to play the perfect game. One more practical application of reinforcement learning is in self-driving cars. An AI agent can learn to navigate streets and highways, obey traffic laws, and react to unpredictable elements in the road like pedestrians and cyclists. All the while, it is learning and improving from feedback. Much like the Snake AI agent, the goal of the self-driving car is to maximize its reward function. For instance, an action that leads to a crash or to a traffic violation would yield a negative reward or a punishment, while an action that gets the car closer to its destination safely would provide a positive reward. Keep in mind, reinforcement learning requires massive amounts of data and computational power to learn effectively, and it may need to explore many wrong paths before finding the right one. And in real-world scenarios, negative rewards can be costly or even dangerous. Now let's talk deep learning, a subset of machine learning which has radically improved the performance of AI models over the last 20 years. Deep learning uses artificial neural networks modeled after the human brain to imitate how humans think and learn. By using multiple layers of probabilistic decisions, they can progressively extract higher-level features from the raw input. In image processing, lower layers of a model may identify edges, while higher layers may identify more abstract concepts like letters, objects, or faces. In the early days of AI, traditional machine learning techniques required explicit programming of features and feature extraction, and that meant to teach a computer to recognize a cat, we would need to program it with specific characteristics like it has ears, it has a tail, it has whiskers, and this is very manual and labor-intensive. With deep learning, you simply show the model a bunch of pictures of cats, and it figures out the defining characteristics all by itself. It's like teaching a child to recognize a cat by pointing at a cat and saying, "This is a cat." As the model sees more cat images, it learns to identify the patterns that are common in cat images. Every time the system makes a correct decision, it strengthens the importance of certain connections, or nodes in the network, making it more likely to make a correct decision in the future. But of course, deep learning also has its own challenges. Deep learning models are often considered black boxes. They can make brilliant predictions, but it's tough to understand sometimes how they came to those conclusions. And this lack of interpretability can be a major hurdle, especially in industries like healthcare and finance, where it's crucial to understand the why behind the decisions. But with ongoing research, we're finding ways to make deep learning models more interpretable and efficient. The game-changing aspect of AI is making predictions drastically cheaper. Predictions used to be very expensive due to the resources and time required for human experts to analyze data. But with machine learning algorithms, we've turned prediction into a high-volume, low-cost commodity. So harnessing AI and machine learning isn't just about automating tasks or cutting costs. It's about gaining insights, making better decisions, and creating innovative products and services. So embrace it, harness it, and thrive in the era of cheap prediction powered by machine learning.